Hello everyone. So in today's lecture we will be discussing about the concept of beats. So before we proceed with the concept of beats, let's first revise about the flowcharts that we were discussing. So as discussed, motion can be classified on the basis of number of particles vibrating. So if there are multiple particles which are vibrating, then we call that motion a wave. And if there is a single particle that is vibrating, then we call that motion oscillation. There are various ways of classifying a wave. For example, waves can be mechanical, electromagnetic, or matter waves. Then waves can be progressive or standing waves. Waves can also be longitudinal or transverse. Similarly, oscillation can be of two types: non-harmonic oscillation and harmonic oscillation. Harmonic oscillation is again of two types: non-simple harmonic and simple harmonic motion. When we talk about simple harmonic motion, then again we have four types. First, the simple harmonic motion can be free oscillation, okay, or it can be free damped oscillation, it can be forced oscillation, or a coupled oscillation. Now we have discussed about all these things in brief in the previous lectures. Today the objective will be to discuss about the superposition of waves and specifically about the beats. So what is the superposition of waves? The principle of superposition is a very powerful principle. It states that if we want to find the displacement of the resultant wave, then it can be found out by the vector additions of the displacements of the individual waves. For example, let's say the displacement of the resultant wave is y net. Then it can be found out by the vector addition of the displacement of each of the waves involved. For example, y1 plus y2 plus y3 and so on. Remember, the arrow indicates that the quantity is a vector quantity. Now, this superposition can happen in various circumstances. We usually discuss about three main circumstances. One is the beats, one is the sustained interference, in which we discuss about proper constructive and destructive interference, and then one phenomena is of the standing waves. So there is just a slight difference in all of this phenomena. For example, in the case of beats, the waves have same amplitude and they have slightly different frequencies. Now what is the meaning of slightly different frequency? We will come to that in a bit. Secondly, the beats also travel in the same direction. So these are the two main points that we need to keep in mind while discussing about the superposition of the waves in case of beats. And then similarly in interference and standing waves, there is some other criteria. For example, in sustained interference, the frequency must be same and the amplitude must be same and they must be traveling in the same direction. In standing waves, the frequency and the amplitude, again they are to be same, but the waves travel in the opposite direction. So let us now start with the concept of beats. So have you ever heard sounds like this? So what is that? So in this particular sound, the amplitude is increasing, then decreasing, then again increasing, then decreasing in a regular manner. So this type of sounds are generated because of the phenomena of beats. So let's discuss how the sound waves and the beats are produced. Beats. So what are beats? So as I told you, if we have two or more waves which are traveling in the same direction, having same amplitude but slightly different frequency, then we get the phenomena of beats. For the purpose of not complicating the things, I will only consider two waves for now. But again, it is not necessary that we only have two waves. There can be more than two waves also. But for simplicity's sake and for the understanding of the concept, two waves are sufficient. So let's say we have two waves. Secondly, they have same amplitude. Both the waves have similar amplitudes. Then they have slightly different frequencies and they will be traveling in the same direction. So these are the points that we need to keep in mind for now. So let's have these two waves. First y1 and the second wave is the y2. Now if you closely look, then you will see that these two waves have almost similar amplitude, but they have slightly different frequencies. If you use the principle of superposition, then you will find the resultant wave, that is y equal to y1 plus y2. Once you get the resultant, you will notice that the waves are in phase at some places and they are completely out of phase at some other areas. For example, here the waves are in phase and here the waves are completely out of phase. So whenever the waves are in phase, we will get maximum amplitude. But when the waves are not in phase, then we will get minimum amplitude. Just to properly imagine the wave, we draw an envelope wave around the resultant. The envelope wave helps us in visualizing the extent up to which the particle oscillate or vibrate. For example, the particle here will not vibrate at all, but the particle here will vibrate a lot. It will vibrate from this end to that end. So what are beats? Beats are the superposition of waves having same amplitude but slightly different frequencies, and they are also traveling in the same direction. For example, both these waves are traveling in this direction, in the positive x direction. If you assume this as the positive x direction, then the waves are traveling in the positive x direction and the resultant will also be traveling in the positive x direction. Now let's discuss a few important terms. First, beat. So what is a beat? Like for example, you must have heard about your heartbeat. So similarly, what is the meaning of beat here? So let's say at t equal to 0, you have a maxima. Then after some time, again the amplitude will become maximum. So one beat consists of the region between two maxima. It can also be defined as the region between two minima, or for that matter, the region between two similar phases. So to keep the thing simple, we can say that the beat is the region between two maxima or between two minimas. For example, this region is one beat because it is from one maxima to another maxima. So this is one beat. Now the second term is beat period. So it is the time interval between two successive beats. Between two successive beats. Then beat frequency. Beat frequency is the inverse of beat period, or we can also say that beat frequency is the number of beats per second. So after discussing about these terminologies, let's move on to one important thing. As I told you earlier that the frequency difference must be slight. What does this mean? What is the meaning of slight? So to understand this concept, let's first discuss one important thing. So how do we hear and how do we interpret sound? So first, sound is produced as a vibration. Usually in day-to-day life, vibration of the particles of air. Then those vibrations travel to our ears. Then from our ears, the sound is sent to our brain in the form of electrical pulses. Now the brain interprets those vibrations as sound. So to process the sound coming from the ears, the brain requires some time. So in this particular process, around 1/10 of a second is required. Now what happens if another sound comes before this 1/10 of a second? Then our brain will not be able to properly distinguish between these two sounds. So if we hear beats which are coming in time which is less than 1/10 of a second or 0.1 second, then our brain will not be able to interpret those beats as different beats, and we will not be able to properly hear the sound of beats like wow, 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 wow. So the beats will not be properly audible. So to properly hear the beats, the time interval between two beats must be greater than 1/10 of a second, which in turn mean that the frequency must be less than 10 hertz. How? Because what is frequency? Frequency is the inverse of time period. So f must be less than 10 hertz. So in order to properly hear the beats, the frequency difference between the two waves must be less than 10 hertz. Otherwise, we will not be able to hear the beats properly. Now there is this term called beat frequency. So this beat frequency is defined as the modulus of the difference between the frequencies of the two waves. For example, let's say the frequency of first wave is 200 Hz and the frequency of the second wave is 205 Hz. Then the beat frequency will be equal to the difference between these two waves. So we will get 5 Hz. Now again, why have we put the modulus here? Modulus is here so that we do not get a negative value of the frequency, because it does not make any sense. So beat frequency is the difference between the frequencies of the individual waves. Now we can easily derive this phenomena, and we will do that in the next lecture. So for now, what do we need to remember is that beats are the superposition of waves having similar amplitude but slightly different frequency. Now why slightly different? Because the time period for our brain to interpret this signal is 1/10 of a second. So we require the frequency difference to be less than 10 Hz. So there must be only slight difference in the frequencies, or I should say the difference in the frequencies must be less than 10 Hz. Also the waves must be traveling in the same direction. So what is the beat frequency? It is the modulus of the difference of the frequencies of the individual waves. So that's it for now. Hopefully you understood the concept of beats, and in the next lecture we will be discussing about how to get the formula for beat frequency.